Everyone, I'm going to try a couple different or more difficult examples with algebraic manipulation. So my first example I'm going to use is, excuse me, I'm just on my phone as well, so if it's a little bit harder to see, it's because it's a little bit smaller area. So I'm going to use a couple different equations, and I'm going to isolate for a couple different variables. So it's going to be a little bit trickier than what I showed you yesterday, and these are harder examples. So just bear with me as I go through some of them. Some of them will use skills that you've learned in the past, and I'll kind of go through it and explain it. Here we go. Let's just start with the first one. So I have v equals u plus a t. So the first thing I'm going to do is I want to make a the subject in this one. So I'm going to isolate for a. So the first thing I'm going to do is I'm going to move u over. So I'm going to subtract u, and then I'm going to subtract u from this side too. So what's going to end up happening here is my two u's will cancel out. So then I have v, I'm just trying to draw that as a nice v, there we go, that's not bad, minus u equals a t. Good, so don't forget I'm isolating for a, so the next thing I'm going to do is the operation between a and t is multiply, so what I'm going to do is I'm going to divide at by t, and I'm also going to move this t over. My two t's are canceled out, and this one, a equals v minus u over t. Do not forget that when we make one of our pronumerals the subject, we need to make sure it's on the left side, so I can rewrite this as a equals v minus u over t. So I'm going to try another one now. This one's going to... So in my next example, we're going to try something a little trickier. So in this one, what we're going to do is we're going to be doing x, come on pen, there we go, equals the root of b squared minus 4ac. So the first thing we're going to do is I'm just going to get a different colored pen. We're going to remember that the opposite of a root is squared. So I'm going to square this side, and I'm going to square my x. So we now have x squared equals, my root and squared cancel out, so I'm left with b squared minus 4ac. The next thing we're going to do is we're going to add 4ac, and we'll add 4ac. So then let's draw a line across, and we these two cancel out. So now we have b squared equals x squared plus 4ac. Sorry, I'm just getting the bottom of my screen. So to get rid of a squared symbol, because b is not fully the subject or fully isolated, I'm going to take the root of b, and then I'm going to take the root, I'm just trying to get a bit more space there, we go, the root, I changed colors, the root of x squared 4ac, and then I'm going to just move things around over to here. I'm just going to move things over to here. My final answer, and I'm going to switch sides and write my final answer all at the same time. So b is now isolated because squared and root are opposite. So I have b. Oh, I changed my pen size. Just let me undo that and make my pen, there we go, narrow again. So we have that b, how did I change it to gray? I have no idea, equals, oh, I think I know why that's happening. Give me a second. Let me just undo. You're not going to see any of that. I just had changed my pen style. So we have that b equals the root, oh, do I have enough room? X squared plus 4ac. Let's see if I have a bit more room down here. b equals the root of x squared plus 4ac. Oh, come on, c, just fit in there. Oh, I can't, I'm too close to the edge of the screen. There we go, I got it, yay. So, and that's all under the root symbol. So my final answer with b as the subject is b equals the root of x squared plus 4ac. The next one's crazy. So I'll try my best on this one to try to explain it. This one's crazy, crazy hard. And it took me a bit of time to figure out. But I thought I'd show you just one last one to really show you something a little bit nuts. But crazy, not outrageous. So to start out, I'll just write this out. So we have 1 over x equals 1 over r plus 1 over s. Whew. So that's where we're going to start. So to deal with this one, we're going to want to make a common denominator. So we have to think of the greatest common multiple of these ones. And you're probably thinking to yourself, Mr. Smith, there is no numbers on the bottom, but there are a greatest common pronumeral. And so the greatest common pronumeral that we can multiply all these by is x rs, and I'll multiply this one by x rs. There we go. And sorry, I just keep, and we'll multiply this one by, oops, I did not mean to do that. And we'll multiply this one by x rs. So that's going to give them all a common denominator. When we do that, I'm just going to do some canceling now. So my, I'm trying to think of a good way to explain this. Okay. Yeah, we'll do it this way. So my x here will cancel out this x here. My r here will cancel out this r here. And my s here will cancel out my s here. Now I'm going to rewrite. So what is rs? I'm going to try to get my laser pointer out just to be able to show you what I'm talking about. So what is the remainder? Rs times 1. Rs times 1 is just rs, and my denominator after canceling out is over 1, so I don't have to worry about that. Next, I'm going to do xs over 1 plus x r. So now kind of gotten rid of our denominators, and now we have everything without denominators. Yay. They are all over 1, so when we cancel it, they are all over 1, but that's kind of where we are at. The next thing we're going to do is I want to get the r's on the same side. So I'm going to go ahead and I'm going to subtract x r and subtract x r. Don't forget that the order in subtraction matters. So now I'm left with xs, and then on this side we have rs minus xr. So at this moment, I'm going to go to a new slide because I've run out of room and I know I can't just squash this in. So we're just going to pick up from right here on my next slide, okay? So I'm just going to pick up right where we left. I left off with, let's see here, it was xs equals rs minus xr. So at this moment, what you're going to do is you're going to use a skill that you learned in year 8 called factorizing. And we're going to look at this and see if we can factor anything out of this. So is there a factor or something that we can take out of both of these terms? They both have r in common, so we can factor out r in both of these, right? Because we can factor out r in both of them, we can then write r bracket s minus x bracket equals xs. Now we need to isolate r, so we got to get r by itself. So the next thing we're going to do is we're going to divide by s minus x and divide by s minus x. And now we have r isolated. So r equals x times s divided by s minus x. How is that for pretty crazy? So there's r isolated, and that's if your original equation, I'll kind of just draw the original just so you can review that. It was 1 over x equals 1 over r plus 1 over s. And that is how you can isolate for r in that one. How's that for some tricky math? Hope you enjoyed. Take care.